Assalamu alaikum guys, welcome. Alright, so in the previous video we talked about the instantaneous dipole, induced dipole, or the van der Waals forces. Now we are going to talk about the permanent dipole interaction. Now guys, I told you intermolecular forces are those forces on which the physical properties of covalent compounds, different covalent compounds, they depend upon, right? So now we are going to talk about the second type of intermolecular force, which is the permanent dipole interaction. Alright, so permanent dipole interaction, as the name suggests, permanent dipole. Over there it was instantaneous dipole, right? Instantaneous meant not permanent, temporary, right? Permanent means it has to be a dipole and it has to exist and it has to stay in that state. It's going to have to be stable in that state, right? Now let's take the very classical example of permanent dipole interaction is HCl molecule. HCl interaction is permanent dipole interaction. HCl contains a hydrogen and a chlorine. It's polar molecule because chlorine is more electronegative as compared to hydrogen. So what it will cause the bonded electrons to shift towards itself, and as soon as the bonded electrons they shift towards the chlorine atom, what will happen? It's simple. As soon as the electrons they are slightly shifted towards the chlorine will get a partial negative character or partial negative charge, whereas the hydrogen will get a partial positive charge. Now same will be the case with another HCl molecule. Now over here you've got opposite dipoles, right? Opposite dipoles are there. This is partial negative and this is positive, and you guys know from your previous knowledge that opposite charges, they'll attract one another. So an interaction forms in between the hydrogen and the chlorine. This form of interaction which is present is called the permanent dipole interaction. Reason? Because it's between two permanent dipoles. Okay, the second classical example is seen in carbonyl compounds. What are carbonyl compounds, by the way? We'll be talking about them in detail when we'll be doing organic chemistry, but carbonyl compounds are basically of two main types in our syllabus. The first one is called aldehyde and the second one is called a ketone. Aldehyde and ketone, just note this down for now. We'll be talking about this in detail later on. Aldehydes are basically those compounds which have the functional group R C double bond OH, and ketones are those compounds which have a functional group R C double bond O R prime. The R is a hydrocarbon chain, the R prime is also a hydrocarbon chain. Okay, so this is how an aldehyde looks like and this is how a ketone looks like. This C double bond O group over here is the functional group carbonyl. Okay, this functional group is called the carbonyl group. Okay, so now in carbonyl compounds, this carbon and oxygen, the carbon is less electronegative as compared to the oxygen over here. So the oxygen will get a partial negative charge and carbon will get a partial positive charge. Similarly, another carbonyl compound, and then we'll get a bond formed in between them, right? The carbon and oxygen. This is also going to be an example of permanent dipole interaction. Permanent dipole, since it's permanent, it's going to be stronger than the instantaneous dipole, induced dipole interaction. So these molecules which are polar have a higher melting and boiling point as compared to the non-polar compounds of the same mass or of the same mass. Okay, so therefore they have a higher melting and boiling point. So this is the example of permanent dipole interaction. This is how it looks like. And this important point, I would suggest that you guys should write it down, that permanent dipole interaction is stronger than instantaneous dipole, induced dipole, and this is seen in polar compounds which have a permanent dipole, whereas instantaneous dipole, induced dipole is seen in non-polar compounds, okay, like hydrocarbons. And this sums up permanent dipole interaction, a very short topic though, but still guys, these examples are very typical, and if you are asked on the exams to write down an example of permanent dipole interaction, I would really highly recommend that you give the example of HCl, because that's the one which has been repeated in the past papers and MCQs and the mark scheme like tons of times. Okay, and that's it. In the next video we are going to talk about hydrogen bonds, the strongest intermolecular force. Okay, it's stronger than permanent dipole, and also of course stronger than instantaneous dipole, induced dipole. Thank you.